Good morning, all. Greetings. This is Dr. P. Ravindra Kumar, working as a professor in Department of Mechanical Engineering, Lakhireddy Baladi College of Engineering. Today, I am going to discuss the thermodynamics, and this is the first unit syllabus. And this blue color line, which indicates that this particular content I am going to discuss for today's class. And the first part of the unit related to the basic concepts. And the second part of the first unit related to the zeroth law of thermodynamics. Now coming to the textbooks, Engineering Thermodynamics by P.K. Nag, Indian edition. Second one is Fundamentals of Thermodynamics, foreign author, that is Sontag Van Willen. This is the very good book. So if you study these two books, you can get very good knowledge in thermodynamics. Then what about the course outcome of this particular course? After undergoing the course, where the student is expected to learn the basic concepts of thermodynamics, what are the laws of thermodynamics, concept of thermodynamics, that is entropy, especially the second law of thermodynamics, property evaluation of vapors and their depiction in steam tables and in charts. The last outcome of this particular course is the evaluation of properties of a perfect gas mixes. Then what is the course education objective of this particular course? So here the intention is that to impart the knowledge of thermodynamic laws and principles to enable the student to prepare an energy audit of a mechanical system that exchange heat and work with the surroundings. So this is the particular content I am going to discuss for today's class. And the outcome from this particular content is you are going to classify the basics of thermodynamic systems. But before that one, what is meant by thermodynamics? How this is obtained? Thermodynamics, two terms are there, thermi plus dynamics. Thermi means it is a heat, which came from the Latin word. Dynamics means power or forces, which causes the motion. So the overall meaning of thermodynamics is nothing but heat or heat power or a force interaction between a system and the surrounding. So we need to observe many general things in nature. So the thermodynamics is directly or indirectly connected for each observation. So this is the thermodynamics where these are all the interconnected things: zeroth law, first law, second law, third law, and which are connected. So that's why we will take it as the four laws of a thermodynamics. Then introduction of this particular course is in most general science, thermodynamics is nothing but it is the branch of a science which deals with the heat and work interaction with the system and the surroundings, or the study of energy and its relationship to the properties of a matter. So all activities in nature involve some energy interaction with the system and surroundings. So the thermodynamics is going to govern the following things, that is energy and its transformation, means the conversion of a low grade energy to the high grade energy or vice versa. Next, the feasibility of a process involving the transformation of energy. So what is meant by feasibility of a process? So when you talk about the process, whether it is a constant pressure process or constant volume process, so that particular process is going to be the feasible or not for this particular study of thermodynamics. Next, the feasibility of a process involving the transfer of energy. And moreover, thermodynamics is going to deal with the equilibrium process. So this is what about the introduction of this particular course. Then what are the areas of application of a thermodynamics? Generally, all the natural processes are governed by the principles of thermodynamics. However, there are certain specific engineering devices which are typically designed based on the thermodynamics. So what are that particular engineering devices? Automotive engines, steam turbines or gas turbines, axial compressors or centrifugal compressors, pumps, fossil and nuclear power plants, refrigeration industries, combustion, geothermal systems, biomedical applications, cooling of the electronic equipments. So all these the practical applications you can find it in application of thermodynamics. Then come to the system. What is meant by system? System is nothing but it is a some definite quantity of a matter or a region in space upon which attention is focused on the analysis of a problem. What is the analysis? Whether it is a closed system problem or it is an open system problem or it is an isolated system problem. So this is what you have to analyze. So that is why the system is defined as it is the quantity of a matter or region in space upon which attention is focused on the analysis of a problem. So for example, to study the quantity of a matter contained within a closed rigid vessel, or to consider something such as a gas pipeline through which matter flows. So this is what the examples, the system where you can analyze. So this is the diagrammatic sketch, and this system, whether it is a closed system or open system or an isolated system, but everything external to the system we can call it as a surroundings. The system plus surroundings you can call it as a universe, and this boundary is nothing but it is an imaginary line which is going to separate the system and the surroundings. System and the surroundings. So these are the diagrammatic sketches you can observe. So the closed system is nothing but the mass is fixed one. Only the energy interactions are happen across the boundary of the surface, across the boundary. Open system is nothing but the mass is entering, mass is leaving, energy is entering, energy is leaving. That means mass as well as the energy transformation, energy transfers across the system boundary. An isolated system, neither the mass transfer nor the energy transfer takes place. So this is all about the system, that is different types of a thermodynamic system. But here, one thing you have to understand what is meant by control volume and the control surface. Control volume is nothing but a region in space. Control volume is nothing but a region in space where much attention is given or it is focused on certain volume. This is the volume, certain volume in space surrounding the compressor. So across the control volume, the control surface, see, observe the control surface. So which is going to cover the inlet and outlet portions bounded by a surface, that it is called the control surface. So control surface is bounded by a control volume. And when it comes onto the boundary, specifically, the boundary may be classified as a fixed boundary and a moving boundary. The fixed boundary is nothing but the fixed one. Moving boundary, once if you give the heat input, the piston is going to move up or down. So this is now here the boundary is going to be moving. In case of an open system, that is example nozzle, the real boundary, how the real boundary which is going to form the inner surface, whereas the imaginary boundary which is connected to the inlet and outlet part. So in open system we may call it as a real or imaginary boundary. In closed system we may call it as a fixed boundary or moving boundary. So here in a closed system, mass is not transferable, only the energy interactions are taking place. Example is gas filled in a cylinder. Note, if a system is defined as a certain quantity of a matter, then the system contains the same matter and there can be no transfer of mass across its boundary. So it is a closed system. However, if a system is defined as a region of a space within a prescribed boundary, then matter can cross the system boundary. So this is the closed system and this is the open system. Apart from this closed, open and isolated system, there is adiabatic system and diathermic system is there. Adiabatic system is nothing but a boundary which is going to allow the, which does not allow the heat transfer. Whereas the diathermic system is nothing but a boundary which is going to allow the heat transfer. So the example for a closed system, you can consider it as a cylinder filled with a removable piston, bomb calorimeter, motor car battery, pressure cooker, kitchen refrigerator, ice cream freezer. So these are the examples you can consider for a closed system. Whereas for open system, the examples motor car engine, water wheel, steam generation, steam turbine. That means some mass is entering, some mass is leaving, and energy interactions are taking place with the system and the surrounding. Isolated system, neither the mass transfer occurs or energy transfer occurring. So example, thermos flask, universe. So these are the examples we can consider in a isolated system. Apart from these systems, there is a homogeneous system is there and a heterogeneous system is there. So when you consider the quantity of a matter as homogeneous throughout its chemical composition and physical structure, you can call it as a phase. So every substance can exist in one of the phases, that is either it may be the solid phase or liquid phase or it may be the gaseous phase. So system consisting of a single phase, you can call it as a homogeneous system. But when a system contains more than one phase, that means liquid phase, solid phase, then you can call it as a heterogeneous system. Now coming to the importance of this control volume, in a closed system, mass is fixed one, whereas in open system, a region through which matter flows is fixed one. Matter flows in fixed. The fixed region in space is called the control volume. So observe the diagram. The fixed region in space. So the fixed region in space. This you can call it as a open system. The fixed region in space is called the control volume. The control volume may be either it may be stationary or it may be the moving at constant velocity. The surface of the control volume you can call it as a control surface. So mass, work and heat transfer may occur across the control surface. If no matter or no mass transfer occurs across this surface, then the control volume becomes identical with the closed system. If both the position and size of a control volume changes, then the control volume is equivalent to the open system. So control volume concept is very useful in the analysis of a fluid flow.